of this sheet, this one has a lot of space at the top because I want to write down the equations that we're going to use here. I didn't write them down for you. I want you to write them down so then you know that they're there as a reference. And plus, the practice of writing them down is going to help you remember them. First thing I want to write down is not an equation, but I want to write down the constant that we're going to use most frequently. What is that? That 4.18 joules per gram degree Celsius. That's the specific heat of water. So I'm going to write that somewhere. The specific heat, which is C. And then I'm going to write in subscript down here, little letters, I'm going to write water. Because the specific heat of what? So the specific heat of water, because remember for every substance, that's going to be a different number, is 4.18 joules per gram degrees Celsius. All right, the first equation we're going to need is the equation for change in temp. The equation for change in temp. So change in temp equals final temp minus initial temp. I'm going to put that up there, and then I can refer back to that. What's the other equation we're going to use? Yep, so Q equals M delta T C, mass times change in temp times specific heat. I'm going to write out, like it is on the board on the cabinets over there, I'm going to write out that equation, this same equation with the variables rearranged. Because what if they ask me to solve for mass? What if they give me thermal energy and ask me to solve for mass? Or what if they give me thermal energy and mass and specific heat and ask me to solve for change in temp? Or what if they give me change in thermal energy, mass, change in temp, and ask me to solve for specific heat? So I'm going to write out those equations with the algebra already done so that I have them ready to go. I've got them at the top of my paper, so if that comes up, they ask me for something other than Q, I already have the algebra done. So if they ask me to solve for mass, mass would be equal to Q over delta TC. These are the same that are on the cabinet over there. It's the same equation, just with algebra done, so it's rearranged. If I were solving for specific heat, it would be thermal energy over mass times change in temp.
I hate that specific heat is C.
Yeah, I know it's weird. It's because specific heat is specific heat capacity, and I think that's where the C comes from.
I don't know. I thought it
Yeah.
was more than the Q.
Really?
Yeah.
All right, the last one, what if they ask me to solve for change in temp? Well, that's going to be thermal energy over mass times specific heat. You can think of, remember, heat capacity means the same thing, so you can think of it as heat capacity if you want instead of specific heat. Or you can think of specific ends in a C. Does that help? All right, this one, first one, what do each of the variables stand for and what are the units? So again, remember, variables are what are we measuring. Units are what are we measuring them in. This one, it didn't, for some reason, I don't know why I don't have it here, but it should be delta T. Delta T, change in T. So you can look back in your notes if you want, because we just did this, but I want you to fill out these right now, and then we'll go over them. I want you to fill them out on your own, though, rather than me doing them together. All right, so what did each of the variables stand for? What is Q?
Change in thermal energy.
Yeah, thermal energy or heat. What do we measure it in?
Joules.
Joules, good. What about M?
Mass.
Mass, what do we measure it in?
Grams.
Grams. Delta T?
Change in temp.
Change in temp, measure it in?
Degrees Celsius.
Good job. TF?
Initial or
Final temp. Final temp, measure it in degrees Celsius. TI? Measure it in? Good job. And then C. C is a specific heat, and we measure it in joules per gram degrees Celsius. Good job. Okay. Number 2 is a change in temp problem, just given final and initial. Number 3 is how much heat, so solving for Q. I want to skip down to number 4. Number 4 says a mug containing 100 grams of water gains 4,200 joules of heat energy. Okay, they're giving us the Q. They're giving us the heat energy. By how much did its temperature change? So this time we're solving for delta T, given the mass, given the Q, and given specific heat. So this is the one that I want to do together. You will do the rest of them for your virtual assignment tomorrow, but this is the one I really want to look at since we're not solving for Q this time. So what are the givens? Let's list the givens first. Good. Mass is 100 grams. What's another one? Good. One more given. We're on number 4.
The specific heat is 4.814 joules or whatever. I can't.
Yeah, okay, and I know that I've got this little like asterisk in between here, and I've got an extra digit here. This is because it's the same sheet that I've used for years and years, and I should have revised it because now, like, you don't really need, that's more information than we need to know. Just like we're not being really specific about significant figures or anything like that. And this is supposed to be joules over grams times degrees Celsius. I don't usually write the time sign in between those two, and I happen to on this sheet. So that's why it looks like that. What are we solving for? Change in temp, delta T. Which means, what equation are we going to use? Delta T equals, because that's what we want to solve for, thermal energy over mass times specific heat. So then when we plug this in, we're going to want to be careful to plug the right numbers into the right spots. So those givens into Q is here, mass is here, specific heat is here. So delta T equals 4,200 joules over mass is 100 grams, and I put parentheses around each one of those quantities to help me keep track of, like, it's not just a random string of numbers and letters. 4.18 joules per gram degrees Celsius. Now when you plug this into your calculator, be careful because these two on the bottom need to be multiplied by each other. So it's 400 divided by, parentheses around that whole bottom, 100 times 418. So practice plugging this into your calculator right now. Because I have an extra digit in there. Because so these numbers, like the specific heats, like the specific heat of water, it's a constant. You could look it up and you could get digits way, way out. We need to round it to some reasonable point. When I originally wrote this, I was using 3 digits past the decimal point. I was rounding to the thousandths. I think that when we round to the hundredth in here, that's plenty. That's totally fine.
So wait, do you multiply the 100 and the 4.18,
Mm-hmm.
and then you? Oh wait.
So depending on what kind of calculator you're using, and if you have parentheses, you could do 4,200 divided by, and then parentheses 100 times 418. Or you might need to do it in 2 steps. You might need to do 100 times 418, and then 4,200 divided by that.
Yeah, well, it didn't come out right because I didn't write the number down right. So.
Okay, so if I do this in 2 steps, what's 100 times 4.18? 418. So then I'm doing 4,200 divided by 418. And what do you get?
A big number.
Not that big, hopefully.
Mine's
10.047. So if we're gonna round to the 10th, it would be 10.0.
I did do that.
10.0 degrees Celsius. Is it positive? Yes. Does it make sense that it should be positive? It says a cup containing 100 grams of water gains heat energy. So yeah, the temperature should increase. Temperature should go up.
I am not getting this.
So practice with your calculator if that's not what you're getting. Try it in 2 steps like this, like what we did right here. So just do the bottom first. So then you're doing the top divided by the math you already did on the bottom.
This is what I keep getting.
I got 415 times 4 for the bottom.
Okay, yep, good. So what you might be doing, Gavin, is doing 4,200 divided by 100, and then times 4.18, because you didn't. Oh no, you're not doing that
I
either.
did 100 times 4.18.
Okay, and you got 418.
418, and divide that by.
Nope, you need to do
Well, yeah, but do 4,200
divided by
yeah.
418. So clear your calculator, then do 4,200 divided by 418.
That's what, yeah, so it's,
And then are you getting 10?